Hello everyone. In this video, I will go through the concepts of relational data models. In my previous video, I have discussed about what is data model is. We also discussed about the evaluation of data model. Now, I have mentioned earlier, in this unit, we will focus on mainly on the relational data models and briefly about the NoSQL, which is non-relation model as well. So in this week video, we will have, in this week, we will go through some of the concepts of relation models. Let's look at the outline of it. So we will start with the relation model characteristics, keys, constraints, and relation algebra. The relation algebra is something you have to complete in your phase one from your two-phase project as well. So we'll do some exercises in class. So before we start with relation data model, let's go back to the previous model we had, which is called as hierarchical data models. There are some limitations of these hierarchical data models. That's why we come up with a new model which will overcome these all limitations or challenges we had in hierarchical data models. So now let's look at the hierarchical data model first. So you can see here it is more like a hierarchy, okay, which means it consists of certain levels. If I go back here, so you can see here we have certain levels here, which is top down approach, starting from top and to the end. We have number of levels here, starting from level 1, level 2, level 3, and level 4. Some of the models or examples of scenarios may have more levels, depend on the database we are using. But in this specific one example, we are only showing the 4 levels here. So let's look at these questions. Let's look at the first one first. Find all the results for student number 2. So in order to look for the result for student number 2, we should know the path of student number 2 record, right? So we need to know that specific student is belong to School of Computing, Computer Science, and student number 2, and we will be able to find the result of student number 2. Then find student number 2 result for ACIT 3910. Again, we have to follow the certain path. So we have to look at the same path and you should stop on 3910. This is for second statement. For the first statement, we have to find all the results, that all the courses, and for the second one, we have to find only specific course, which is ACIT 3910. So the results it's displaying, it consists of the course code. These are the marks, and these are the grades. HD is high distinction. D is distinction. C is graded here. P is for pass. And N here is for fail. So what will happen in case if we want to look for the result of only ACIT 3910, which means the result should display all the list of students who are enrolled in ACIT 3910. So for that, we have multi-path to be followed, which means we have 2 students here. We have to follow this path and this path. So what was the challenges here? As a database administrator, we need to know the path because we are saying that these are predefined paths. Okay. So we are saying that these are predefined paths. So we should know as a database administrator these paths which make it more static or fixed and difficult for database administrator to retrieve the information. So this is the first challenge. The second challenge here is that inflexibility and the redundancy, which means there is no flexibility in retrieving the information. Also, there are chances that some of the information will be duplicated. To overcome this issue, we come up with a solution as a relation model. So, what are the characteristics of the relation model? So, first of all, it is developed by E.F. Cott in 1960s. He come up with the solution by replacing those predefined links with the values. So in this specific data model, we focus on the values. The language we use here is called as a standard query language, the SQL or SQL. And as we said, it's a data model. I already have discussed this data model earlier. So the data model is made up of three components: data structure, entities, attributes, and records, and so on. Operators means computation, so we have a calculus, we have relational algebra, which will focus on in this specific course. Then we have a constraints. The constraints are mainly a rules such as domain. We have something called as an entity. We have referential, and we have enterprise as well. So these all components make a data model. So this is a revision from previous class. So here we have a table. So database name is called from Tiny College and table name is employee. So it's taken from your essential textbook, which I have given to you during the week one. So you can refer to it. So we have discussed the entity, tuple, field, primary key, and domain. So how we can identify the entity here? The entity name here is an employee. We said the table is called as an entity. So entity name here is an employee. If you are saying the tuple, we said the tuple is row and record, which means each entity consists of number of and records. Then we have a fields. The fields means the vertical direction. In vertical direction, we have certain columns, certain attributes, or we also call them as a fields as well. So these are these are fields, attributes, or columns, or we also name sometimes as a properties. Then we have a primary key. We said that to identify each record, we need to have a unique ID, so unique key. In this specific example, the unique key here is employee number. How we know that? If you look at employee number, each of the record here is unique. It's not duplicated. None of the value is repetitive. This is what makes it unique as well, and it is identifying each record uniquely. Then we have something called as a domain. The domain here is means that set of allowable values. Okay. So for example, if we look at DOB, so we can set our domain to set of ranges as well. So for example, we can have an employee date of birth which is not less than, let's say, which is not less than 19040. Okay, which means we have only ranges starting from before after 1940. because our company might not be that old, and so we will have a database which will not have people who are born before 19040. Okay. So this is a domain, and I have given one more example during the class, which was the grades. We said the grades were need to be between 0 to 4, right? It's a set of allowable ranges. So if we have something negative, it's not acceptable. Something more than 4, it's also not acceptable. And also the data type itself. So the foreign keys. So you can look at here, we have two tables. One is employee. This one is an employee. And then we have a department. Okay. So for the employee, you can see here we have a link between employee and department, because one employee is belong to one department in the organization. So in order to link these two tables, we need to have a foreign key. So here we have primary key employee number, and department code is also a primary code, which means those two will identify each of the record in these two entities uniquely. So in order to link them together, we need to have a foreign key. To create a relationship between employee and department, we need to have a foreign key. How we can do it? The primary key here in one table will become a key in another table, and we call it as a foreign key. There are certain characteristics of foreign keys. These can be duplicated and it can be null also, which is opposite of foreign keys. Okay. Now let's look at some of the properties of relation. So first of all, the first property, basically these properties make it a valid relation. So if you remember in exercise 1, week 1, we have discussed that what is a good design and the bad design. So in that, I have discussed that you have to come up with the assumptions, and I will explain that what makes your table valid and invalid as well. So if you look at the distinct relation names, so each table we will have it here will have a unique name. We cannot have a database or schema which would repeat the table. So for example, if we have employee, there will be only one table for the employee. There will be one table only for the department. Same, the second property, distinct attribute names, which means each attribute we will have it here should be unique as well. It should be unique. We cannot repeat any of the attributes. For example, we cannot have employee date twice in our table, which will make it invalid. Okay. Now we have atomic